Hello students, in this video we are going to talk about chi-square analysis. Analysis of variance will be dealt with in my next video. So far we have seen how to carry out hypothesis testing with one population and one sample, for example z-test or t-test, or if we have two populations and when from where we take two samples, z-test or t-test, although that is not in our syllabus. But when we have more than one populations, then we can use chi-square as well as ANOVA. Now, this to understand this in more depth, I suggest you go through. You can pause the video and go through this explanation for better understanding. Okay. So chi-square we can use for various purposes. We can see that the chi-square can be used when we have different samples and we have proportions from different samples, and whether those different sample proportions are having a significant difference among themselves or they are coming from the same population. So that is what we try to prove. So we call it the chi-square as a test of independence. Why we are saying independence? If we are considering two variables, whether these two variables affect each other or they are independent. That is why we call it test of independence. To understand this in more detail, we will take this example and try to understand how to apply chi-square test to this particular example. Suppose that in four regions, the National Health Care Company samples its hospitals' employees' attitude towards job performance reviews. Now, for example, if you see here, the table clearly shows. So they have offices in Northeast, Southeast, Central and West Coast. And they have employees there. So they have sampled those employees. And the question they are asking is whether there are present method of performance appraisal or performance review, which is basically, you can see here two reviews a year is the present method, and the new method proposes quarterly reviews. That means you will have three reviews a year. So how many number of people or number of employees prefer the present method and number who prefer the new method? So this contingency table gives you this information, and you can add the total. That number who prefer present method is 279, number who prefer the new method is 141. And you have the Northeast, you have selected 100 employees, Southeast 120, Central 90, West Coast 110 employees. So when we set up the hypothesis, we can write like this. Let Pn be the proportion of Northeast who prefer present plan. Let Ps be the proportion of Southeast who prefer the present plan, like this. And the hypothesis setting will be like this, that null hypothesis will be these four proportions from four different regions are having no significant difference. So null difference, that is why this is null hypothesis, that these proportions are equal to each other. And alternate hypothesis that those proportions are not equal. So this is alternate hypothesis. And for this we are going to use observed and expected frequencies. Now so what we have got here are the observed frequencies. How to calculate the expected frequency is this. Expected frequency FE is row total into column total upon grand total. So whenever we want to find out for this particular cell, the row total is this, the column total is this. So this into this divided by the grand total. So when we use this formula, we can calculate FE for all the cells. And these are the values we have got here. 68 cell will be the FE will be calculated for this cell. 279 into 100 divided by 420. Then for 75 wala cell we'll use 279 into 120 divided by 420. For this cell we will use 141 into 90 divided by 420. So like this we have calculated the expected frequencies. Then the chi-square statistics is defined as chi-square equal to summation of FO minus FE the whole square. The observed frequency minus corresponding expected frequency, the whole square divided by the expected frequency. So if you go by step, you can see here, these are your expected observed frequencies and corresponding sales expected frequencies, which we have got from these two tables. And then this is the difference square, and difference square upon FE will give you this. When you add all this, you will get your chi-square. So this is your chi-square by calculation. Now to check the hypothesis, we have to use table. For chi-square tables are available, where we will try to find out the critical value of chi-square or table value of chi-square, and the rejection area and acceptance area. For that we will require the calculation of degree of freedom. So degree of freedom in this case is given by number of rows minus 1 into number of columns minus 1. So how many number of rows we have in our contingency table? 2. 2 minus 1 is 1 and 4 minus 1 is 3. So 3 into 1 is 3. So our degrees of freedom is 3 here. And they have asked us to use alpha equal to 0.1 level of significance. So what we are going to do, we are going to check for alpha equal to 0.1 and 3 degrees of freedom. So if you go to the table here, this is the area under right tail which we want 0.1, but this one is having different values. So go to the part B of the table and you will see here 0.1, and the degree of freedom is 3, that is the third row. So here we will go for the third row, which is 6.251. So chi-square calculated is 6.251. So if you put it here, your chi-square by calculation is 2.764, and by table it is 6.251. So clearly this is your rejection area, this is your acceptance area. So it is 2.764 is clearly lying in the acceptance area. Hence we accept the null hypothesis that there is no significant difference in the proportion who accept the or you who prefer the present method. So that is going to be our null hypothesis, that there is no significant difference in 4 regions with reference to the acceptance of the new plan, or acceptance of the present plan, sorry. So this is the accept, not reference to the preference, yeah, preference the present plan, right? So there is a small mistake here, let me correct it here only. So here, no significant in the 4 regions with reference to the preference to the present plan. Okay, so this is the hypothesis conclusion. Thank you.